Next, we have a tech demo presented by Emma Bates, founder and CEO of Cachai.
I'm afraid I don't have a demo for you, unfortunately. It's more of a tech talk. Do we have any military historians or strategists in the audience? I see a couple of hands up. Do you know what strategies people used to fight 1,000 years ago, before the Industrial Revolution? Anyone? What was the first one, though? Melee. And then we industrialize, we have a lot more people, we can, like you said, mass. What beats mass? We did it in World War II. Planes, tanks. Maneuver. What beats maneuver? Swarming. But what's different about swarming from mass and maneuver? Isn't swarming just maneuver en masse by robots? Here's what I mean. If you've been to drone exercises or seen, the Chinese New Year, generally follow this topic, you'll recognize these models. You've got what I call force multipliers on the left, leader, follower, one to many. And on the right, we have the kind of terrifying and beautiful light shows, pre-programmed maneuver at a grand scale, 1,000 drones operating in perfect sync. And if you think of the most impressive drone swarm you've ever seen, I bet you it falls into one of those two categories. But what happens if, say, in a leader-follower context, if they lose connection between the leader and their followers? That's a single point of failure. The rest of the followers don't know what to do anymore. They had a common operating picture in their leader, in their controller, but they lose it with that single point of failure. Now, the drone show has the opposite problem. If I reached out, with a gigantic King Kong hand and swiped down half of those drones, would you see a dragon anymore? No. It would look kind of silly. It wouldn't be a dragon anymore. And this is frivolous and it doesn't really matter, but the mission has failed. And do the rest of those drones know what to do? Can they reconstitute themselves in a smaller or a lower fidelity dragon? No, because they have no common operating picture. There's no single point of failure, but when some of them are gone, they never had that common operating picture to begin with. So I have a hot take for you all. I think that if the word swarming is going to mean anything, if it's actually something that beats maneuver and mass, it should be different than maneuver and mass. I think you need a hive mind. A hive mind would be able to maintain a common operating picture among all of the participants without a single point of failure. Now, there are a lot of really smart people who have been working on this for decades, and some of them are probably in this room right now who will say, that's impossible. We've tried, we haven't gotten there. Not even starlings, not even bees actually have a hive mind, right? And the reason they say that is because the folks who have been working on this for decades come from industries like robotics and flight automation software and AI. They come from fields that fundamentally start with a single node system. And then they ask that single node system to become very intelligent, and they ask it to talk to other single node systems and stay on the same page. And so, yeah, from that perspective, it is probably impossible. I don't know how to do it from there. But if you start from the perspective of a distributed system, we in the distributed systems world, we start with a multi-node system. Our basic premise is tens, hundreds of thousands of computers all on the same page with a common operating picture and no single point of failure. That problem is very different. Now, if we want to get to drone swarming, starting from there, we're taking something that works in one context and making it work in another. What I'm saying is, hive minds exist. Has anyone heard of the term Kubernetes from computer science? I'm seeing a couple raised hands. Kubernetes is a hive mind. That's how the cloud works. Kubernetes maintains a common operating picture with no single point of failure. That distributed system creates the trustworthiness and resilience that we all love about using the cloud. There's a single source of truth, but no single point of failure. And you know that when servers fail here and there, as they do, the whole system will continue to work. Because all the computers are in agreement about where everything is and what needs to happen, and they're all ready to step in and pick up the slack. That process is called consensus, and I won't get into it technically with you. I know this isn't the crowd for that. But that's the point. They have a common operating picture. They reach it by consensus. In computer science talk, it's called their shared state. They maintain and manage that shared state through that consensus process by consenting on everything that happens. So cool, problem solved, right? You just get some cloud engineers, some Kubernetes engineers to put that on drones, and we'll have consensus and state management on drones, right? I mean, you can probably guess that that's not exactly the answer. You know, cloud engineers are used to working in a data center, which is an environment with powerful hardware, all of the compute and network and memory that you could possibly want. It's protected. Everything is hardwired together. Nobody's shooting at a Kubernetes cluster in a data center. And so, you know, in a data center, the computers get to kind of hold hands and get to know each other and look each other in the eye and develop trust and use shorthand. It's basically the perfect environment to reach consensus thousands of times per second in a way that is trustworthy. Trying to do that on tiny drone hardware over wireless connections while you might be being shot at in an environment that is not conducive to trust, that's a whole different problem. But that's what has stood in the way of a hive mind for drones. Solving that is the key. And that's what we've done at Cachai. Here's the other thing policymakers need to know. There's not a lot of cutting-edge research happening in America on putting consensus and state management to work on drones. Here's a representative sample, and I don't know if you can see the small text, but you know, this is what the research and development on that, moving this topic forward, looks like. And you might notice that they're all coming out of Chinese universities. That brings me to why all of this matters. If nobody ever achieved a hive mind among drones, we'd be fine doing exactly what we're doing. Leader, follower, drone shows, pre-programmed. But I think these papers are getting there. I think they're on the right track, and I think they're going to achieve their goal. And I say that because we're getting there too. I recognize what they're doing. So we've got state management and consensus figured out. All it takes is to combine that with the robotics and the flight autonomy software and the AI, all of those other pieces that are probably here in the audience today. Ultimately, I think what we want is systems that figure out how to execute the commander's intent. And that requires teamwork and adaptability. It requires not just individually intelligent machines, but collectively intelligent groups of machines that allocate tasks and resources efficiently and adjust to changing circumstances dynamically. When you combine that with rapidly emerging AI tools, it's capable of taking human language commands, combining those with contextual imperatives that are important to all of us, like minimize human casualties, and before you blow up a building, cooperate to lift all the children to safety, right? It's a system that perceives when plan A is failing and plan B needs to be implemented and can implement Plan B as a group. I'll leave you with this. Ukraine has built so many drones. What if those drones could leverage a hive mind? What if we implemented this as a safety mechanism among commercial air flights to avoid crashes? What if cars were able to share a common operating picture on the road and avoid hitting each other because they know the decisions that each other is making? I see a future in which drones are not just a force multiplier, but a trusted partner in solving complicated and important problems for humans. Thank you. Let's get started.